What I want to do in this video is try and prove to you the cubic formula. The cubic formula. So let's say we have a cubic equation of the form ax cubed plus bx squared plus cx plus d is equal to 0. And we want to find a general formula which will allow us to solve this equation. So the first thing I'm going to do is make a substitution. I'm going to make the substitution that x is equal to y minus b over 3a. And it turns out that this substitution is going to be really useful in helping us simplify this equation. It's going to allow us to get rid of the x squared term, which is going to let us solve this equation in general. So let's make that substitution. So all we're going to do is we're going to say that a times, everywhere we see an x, we're just going to write y minus b over 3a. So a times y minus b over 3a cubed plus b times y, plus b times y minus b over 3a. And we're going to square that. And we just got our plus c times y minus b over 3a, and then we have our plus d. We have our plus d is equal to 0. So now we're just going to, obviously we're going to have to multiply these terms out, and it's going to allow for some pretty good simplification, but remember that if we have some a plus b squared, that's just going to be a squared plus 2ab plus b squared. So let's use that. Another thing we're also going to use is a plus b cubed, which should be quite intuitive to you by now if you're watching this video. A plus b cubed, and if you don't remember, I'm just going to write it down. It's going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. That is the expansion of a plus b cubed. So let's use this information to help us expand out these terms. So let's expand out this y minus b over 3a cubed first. So let me go ahead and copy that so I don't have to write it out again. Let me go ahead and copy and paste that. And so let's go ahead and expand this out using what we know. Alright, so it's going to be equal to, so y cubed, we take the first term and we cube it. It's going to be y cubed plus 3 times y squared times our b, which is negative b over 3a. So times negative b over 3a. And then we've just got our plus 3 times our a, which is y, times our b squared, which is negative b over 3a squared, negative b over 3a squared, and then we've got our plus b cubed. So we're going to take this negative b over 3a and we're going to cube it. So plus negative b over 3a cubed. Right, now let us go ahead and continue multiplying this out. So what are we going to have here? We're going to have a y cubed minus, we're going to get a positive times a negative, so we're going to get a minus by squared over a. As you can see, the 3's will just cancel. And then we're going to be left with minus, actually, we're going to get a plus 3y times b squared over 9a squared, right? Because we're just expanding out this b squared, and then we're just going to get a plus negative b cubed over 27a cubed. I've really just squared that term and cubed that term. So when you square something, you multiply the top and bottom. You square both the top and bottom, and when you cube it, you square both the numerator and the denominator. So we're really left with y cubed minus by squared over a plus this 3 over 9 is just going to cancel to a 1 over 3. So we're just going to be left with by squared, b squared y over 3a squared. Since the 3 and the 9 will just simplify. So over 3a squared. And then we're left with a negative here. Negative b cubed over 27a cubed. So there we go, that's what all that simplified to, and now all we need to do is just take y minus b over 3a squared. So let me go ahead and copy that. So I've got that term. So I've got y minus b over 3a squared. So let me go ahead and use this fact that up there. So it's just going to be a squared. So our a is our y. So it's just going to be y squared plus 2 times our a, which is y, times our b, which is negative b over 3a, plus, we're going to get our plus b squared. So negative b over 3a squared. And so let's see what this simplifies to. So we're going to be left with our y squared. We're going to get a negative here. We're going to negative 2by over 3a. And here we're just going to square the top and bottom, so we're going to get plus b squared over 9a squared. Simple. That's it. So now we can just rewrite this. We've expanded it out, so now we can just rewrite it into our original equation. So let's see if we can go ahead and do that. So let's take a look at our original equation. We have it up here. So all we're going to do is we're just going to take if we look at this term here, this is simply the expansion of the y minus b over 3a cubed. And if we look at this lower term down here, if we look at this term that I'm highlighting in blue again, this is just the expansion of y minus b over 3a squared. So all we're going to do is we're just going to replace it. Wherever we see those terms, we're just going to replace them into our original equation, and we should, after we multiply it out, we should see some simplification occurring. So let us go ahead and replace everything. So let me go ahead and copy this. So I've copied that. Let me scroll down a bit. And I cut that 2 off, so let me write that 2 back in quickly. Alright, so let's replace the terms. So now we're going to get a times our y minus b over 3a cubed. Well, we figured out what that was. So let's just replace that. So I'm going to copy that, and I'm going to paste it so I don't have to rewrite it. So there we go, there's our y minus b over 3a cubed term. Let me put it in parentheses. There we go. And then we've got our plus b times our y minus b over 3a squared. Well, we figured out what that was as well. We just expanded it. So let me go ahead and copy and paste that. I could just write it out, but let me just copy and paste it. So there we go. Alright, let me put that in parentheses to make it clear. Alright, let me put that into parentheses. And then we're just going to have our plus. We're going to have plus c times y minus b over 3a plus d is equal to 0. So I'm just going to copy and paste that. And so this is what we're left with once we expand everything out. So this is what it all simplifies down to once we expand it out. But now all we have left to do is just multiply these constants, and then we are going to simplify the expression. So if we take a look at what we originally had, so originally up here we had this expression here, and if we go back down, we've managed to expand out the cube terms and the square terms. But now let's just multiply out, let's expand these out, and we're going to see some simplification. So we get a times y is ay cubed minus by squared, the a's will just cancel, and then we'll just be left with plus b squared y over 3a minus b cubed over 27a squared. Now let's multiply this b times inside the parentheses. And we're going to be left with by squared minus 2y over, minus 2b squared y over 3a, and then plus b cubed over 9a squared. Alright, now the c, let's multiply the c out. We're going to get plus cy minus bc over 3a, and then we're going to have our plus d is equal to 0. Now let's see if we can group any similar terms together. So let us have a look here. Well, immediately we see this negative by squared. This negative by squared and this by squared, they're just going to cancel out. And let me get some orange here. We have this b squared y over 3a. And we also have this minus 2b squared y over 3a. The denominator is the same. And if we look at this term here, if we look at this b cubed over 27a squared, that is very similar to this b cubed over 9a squared. It's just the denominator is just a third of it. So we can go ahead and simplify that pretty easily. So anyway, let's just rewrite it. So we have ay cubed, and then we're going to have this plus b squared y minus 2b squared y. So we're just left with a minus 1b squared y. So we're just going to have, so b squared y minus 2b squared y, that's just going to give us a negative b squared y over 3a. And now let's have a look here. We've got, so this b cubed over 27a squared. We want a 27a squared in the denominator here. So let's just multiply the numerator and the denominator by 3. So if we do that, we're just going to be left with, if we just multiply the top and bottom by 3, we're just going to be left with 27a squared in the numerator, in the denominator, and 3b cubed in the numerator. So that is equivalent. So we're going to be left with negative b squared y over 3a plus 2b squared y over 3a. We're going to be left with this negative b cubed plus this 3b cubed is going to give us 2b cubed over 27a squared. But anyway, now we're just left with a plus cy minus bc over 3a. And then we have our plus d is equal to 0. So that simplified quite nicely. And now let me try and group some of the y terms together. Let me try and rewrite this. So we're going to be left with ay cubed plus, let me write our cy here. Let me get my y terms together. Minus b squared y over 3a. There's our y terms. And now let's just rewrite whatever's left over. It's not going to be in terms of y. Let's just rewrite. So we've got our plus cy, we've got our negative b squared y over 3a. So we've just got our 2b cubed over 27a squared. And we've got our negative bc over 3a. And we've got our plus d is equal to 0. And now what we're going to do is we are going to factor out this y. We're going to factor out a y here. So let me take out a y. So we're going to have c minus b squared over 3a, and we factored out a y. So let me just put the y right there. And then we've got our everything left over. And I'm going to put it in parentheses, everything left over. So it's 2b cubed over 27a squared minus bc over 3a plus d is equal to 0. And let me just chuck that in parentheses so you can see what I'm about to do here. That's a bit messy. Let me tidy that up a little bit. So now all of that original expression, after we made that substitution, that we've managed to simplify that original expression. Once we multiply out the expression, what we're going to be left with is this right here. And I'm going to make a substitution here. I'm going to make a couple of substitutions, actually. Well, actually, before I do that, let me just go ahead and divide everything by a. I think that'll help us all out a little bit. So let me divide everything by a. What are we going to be left with? Well, we're just going to be left with y cubed here. The a's are going to cancel. We're going to be left with c over a minus b squared over 3a squared y. Let me write that out. And then we're just going to be left with plus. We're going to be left with a plus 2b cubed over 27a cubed. Remember, we're just dividing everything by a, minus bc over 3a squared plus d over a. And all of that is going to be equal to 0 over a, which is just 0. Now, let us make the couple of substitutions, which I said earlier. Let us set e. Let us say that e is going to be equal to c over a minus b squared over 3a squared. We're just going to let that equal to e. All of that is going to be e. Let us say that if let us say that f is going to be equal to this 2b cubed over 27a cubed minus bc over 3a squared plus d over a. Let's let all of that be equal to f. So what are we left with? Once we simplify, we're just left with y cubed plus ey. Remember, we let all that equal to e. Plus f. Remember, all this e and this f, they're just constants. They're just values in terms of a, b, and c, and d. So y cubed plus ey plus f is equal to 0. That's what it simplifies down to. So this is the result we get once we simplify everything. I'm trying to copy this, but it's not letting me. So instead of copying it, I'm just going to rewrite it out. I'm just going to go up here and rewrite this. So I got everything simplified down to this. I've got y cubed plus, let me get that same orange, plus ey plus f is equal to 0. So that is what everything simplifies down to. So now, let us make another substitution. Let us say that y is equal to z plus s over z. So it's going to be z plus s over z. And let me make another substitution. Let me say that this s is going to be negative e over 3. And you'll find that after I make these substitutions, we're going to simplify it even more. So remember, e and f are just in terms of a, b, c, and d, and y is just in terms of x, really. So we've got our y cubed, but we know that y is just z plus s over z, so we're going to get z plus s over z cubed, plus our ey, and y is just z plus s over z, and then we have our plus f, and then we have our plus f is equal to 0. So let us go ahead and multiply this out. So we know that any quantity a plus b cubed, let me just remind you here, that's just going to be a cubed. It's just going to be equal to a cubed. Let me rewrite that. A cubed plus 3a squared b plus 3ab squared plus b cubed. And that is going to be, let's use this to expand out z plus s over z cubed. So z plus s over z cubed, that is going to be equal to, it's our z cubed plus 3z squared times our b, which is s over z, plus 3 times our a, which is z, times our b squared, which is s over z squared, and then plus our b cubed, which is s over z cubed. So that's all that's going to be equal to. So let's go ahead and simplify this. So it's z cubed plus 3zs. The z's are just going to cancel. So 3zs. Now the z's are going to cancel here, and we need to square that term, so it's going to be s squared over z squared. And then if we cube this term, we're going to be left with s cubed over z cubed. Alright, now let us continue simplifying this. So we have z cubed plus 3zs, and then one of the z's is going to cancel in the numerator, so we're going to be left with 3s squared over z, I believe. So 3s squared over z. And then we just have our plus s cubed over z cubed. So now that we've expanded that out, let's go ahead and plug this back into our original equation up here. So we've just expanded out z plus s over z cubed. So let's just write it back to how it was. So let me just get rid of this equal sign. So we've figured out z plus s over z cubed. So let's just put that straight back in. So we're going to have our plus, our e, sorry, not ey. We're going to multiply this e out. So we're going to get ez plus es over z. And then we're just going to have the plus f is equal to 0. So let me just write that in pink. Plus f is equal to 0, or magenta. Plus f is equal to 0. So now let's just go ahead and multiply everything by z cubed to try and simplify this out. So we're making progress. So we're going to get z to the 6th plus 3z to the 4th times s plus 3, I believe this is going to be 3s squared z squared, 3s squared z squared, and then we're just going to have plus s cubed, plus ez to the 4th, plus esz squared, and then we're just going to have plus fz cubed, and all of that's going to be equal to 0. So now let us make this, remember we defined earlier s is just equal to negative e over 3, so let's just plug that in. So let's write that down. So we're going to get z to the 6th. If we simplify, it's going to be plus 3z to the 4th times our s, which is just negative e over 3. So it's just negative e over 3. So everywhere we see an s, we're going to replace it with negative e over 3. So plus 3 times negative e over 3 squared times z squared plus s cubed. So that's just going to be negative e over 3 cubed plus negative e over 3 cubed. And then we have plus e times z to the 4th. And then we have plus e times our s again, which is just negative e over 3, times z squared plus fz cubed. And all of that's going to be equal to 0. So now let's just multiply out these negative e over 3 terms. And we're going to see some huge simplification occurring. Because that's the way we've defined the problem. That's why we've made these substitutions, so we can simplify it. So let's rewrite this. So it's going to be z to the 6th. So these 3's are going to cancel, and we're just going to be left with negative ez to the 4th. And here if we multiply out this negative e over 3 squared, we're just going to have, what is this going to be? It's going to be, no, that's not right. 3's will cancel, and we're just going to be left with e squared over 3, because, yeah, e squared over 3 z squared. And then we've got our plus, well, it's just going to be a minus, actually. It's going to be e cubed over 27 once we cube the numerator and the denominator, and then we've just got our plus e times z to the 4th. And then here we're just going to be left with a minus e squared over 3, e squared z squared over 3, so minus e squared whoops, this is meant to be a plus. That should be a plus, because we're going to get e squared over 9, and then times that by 3, we're going to get z squared over 3. So this makes sense. So it's going to be, anyway, we had e squared, z squared over 3 here, and then we're just going to have our plus fz cubed, plus fz cubed is equal to 0. So now we can see some things beginning to simplify. We've got this negative ez to the 4th. This negative ez to the 4th is going to cancel there. We've got this positive e squared z squared over 3, and this negative e squared z squared over 3. So all we're going to be left with is z to the 6th. I'm going to write out this plus fz cubed. And then we have this minus e cubed over 27. That's all we're left with, is equal to 0. And so there we go. This is what we're left with. So now, let's make one final, well, it's not a final substitution, but it's another substitution. It's going to be, we're going to let u equal z cubed. That's it. U is going to be equal to z cubed. So if we do that, we're going to be left with u squared plus f times u, and we're going to have minus e cubed over 27. And this is just a quadratic equation in terms of u. So we can solve for u, which is going to let us solve for z, which is going to actually let us solve for our y, which is going to let us solve for x. So we've got u, using the quadratic formula, it's going to be negative f plus or minus the square root, let me rewrite that a bit tidier, the square root of b squared, so our b squared is just f squared, I'm not going to write out the quadratic formula, we should all know this, minus 4 times a times our c, which is just negative e cubed over 27, and all of that over 2a, so it's just going to be all over 2. So let's just simplify this a bit. So we're going to be left with negative f plus or minus square root, let me rewrite that square root a little bit tidier, the square root of f squared, and now we're just going to have a plus here, we're going to have a plus 4e cubed over 27, and all of that we're going to divide it by 2. And now we can simplify this a bit further. So let us rewrite this as u is going to be equal to negative f, let's divide everything by 2. So negative f over 2 plus or minus a half times the square root of what we had in here. So it's just going to be f squared plus 4e cubed over 27. So now let's bring this 1/2 inside the radical. So let's bring this 1/2 inside the radical. So we're going to have negative f over 2 plus or minus the square root of a quarter, because the square root of a quarter is just a half, right? A quarter times everything inside there, so it's going to be f squared plus 4e cubed over 27. So now we just have to multiply this 1/4 times everything in the parentheses, and we will have simplified it quite significantly. So let us rewrite this. So we have negative f over 2 plus or minus the square root of, so f squared over 4, we're just dividing everything by 4, or multiplying everything by 1 over 4. So plus e cubed over 27, the 4's are going to cancel. So this is all we're left with. So that is our u. So this is negative f over 2 plus or minus, we can simplify inside the radical, the square root of, what's this going to be? F squared over 4 is the same thing as f over 2 squared, right? Same thing as f over 2 squared, and e cubed over 27 is the same thing as e over 3 cubed. So that worked out pretty nicely. So we've got our 2 possible values of u. So now that we know our 2 possible values of u, we can work out our possible values of z, which is going to allow us to find our possible values of y. But anyway, what did we have? What did we what did we get to so far? Let me rewrite it. So we got that u is going to be equal to z cubed. That's what we defined u being equal to. I think we read originally. And so we get u, we've got our two possible values of u using the quadratic formula. So we got negative f over 2 plus or minus the square root. I'm just rewriting out what I had earlier. It's going to be f over 2 squared plus e over 3 cubed. So those are our two possible values of u. And what I'm going to do is I'm going to define one of the values of u as a variable. Let's let v equal the positive value of u. Let's let v, let me make it clear, that is a v. I'm making it clear. So v is going to be equal to our positive value of u. It's going to be negative f over 2 plus the square root of la-di-da-di-da, f over 2 squared plus e over 3 cubed. And let's let another variable, let's let w be equal to the negative value of u. So it's going to be equal to negative f over 2 minus the square root of f over 2 squared plus e over 3 cubed. So we've just defined the two solutions for u in terms of two different variables. So now, one interesting fact that you should know is that of any quadratic equation, if we multiply the two roots, the two solutions together, you're just going to get the constant term. So here, if we multiply VW together, we're going to get the constant term, which I believe was e cubed over 27. And this is a very useful fact which we're going to be using to help us solve the cubic. So if you don't believe me, let's have a look down here at the original quadratic. We see that the constant term, the constant term was negative e cubed over 27. So we look at the original quadratic, and we see that the constant term was negative e cubed over 27. So when we multiply the two roots together of any quadratic, we're just going to get the constant term. So it's actually going to be negative. It's actually going to be negative e cubed over 27. That is going to be what this product of the two roots are equal to. So we know that z cubed was equal to u. So we know that z cubed is either equal to v or z cubed is equal to w, because those are the two possible values of u. This is pretty easy so far. So now we have to go back and look at the three complex values of u. So let me draw up my coordinate plane here. Let me put my imaginary axis here. Just to make it clear what I'm doing, let me just put my real axis here and my imaginary axis up here. And so if let me draw the unit circle. So let's say this is the number 1 plus 0i here, and I'm going to go around the unit circle. I'm going to go 2 pi around the unit circle. I'm going to get right back to where I am. So whenever I add 2 pi, I'm just going directly back to the beginning. So when I write the number 1, I could write that as e to the 0i, or I could also write it as e to the 2 pi I. So I could write v as v times e to the 2 pi I, because e to the 2 pi I is just going to be equal to 1. Same as e to the 4 pi I, and same as e to the 6 pi I, and same as e to the 32 pi I. Or any multiple of e to the any even multiple of pi I, it's just going to be 1. So z cubed could also be equal to v times e to the 4 pi I. And so on. So we know that e to the 0i is just going to be equal to e to the 0, which is just 1. So we know e to the 2 pi I is also going to be equal to 1. and e to the 4 pi I is going to be 1. And we could do e to the 6 pi I, but what you'll find is that you just get a repeat solution. But let's go ahead and just solve for z now, which will allow us to solve for y, because y is in terms of z and s is in terms of e. So anyway, we've got z as a cube root of v, and we've also got z as the cube root of v times the cube root of e to the 2 pi I, which is the same thing as e to the 2 pi I over 3. And we've got z is also equal to the cube root of v times e to the 4 pi I, so it's just going to be the cube root of v times e to the 4 pi over 3i. So now, what are we going to do now? We could also say, z is equal to the cube root of w, z is equal to the cube root of w, e to the 2 pi I over 3, but you'll just find that we get repeat solutions. But for now, let us just work with what we have right here. So let me go ahead and scroll up, get some real estate. Let me go ahead and write down what we have so far. So let me scroll up. Alright, so we know that e to the I theta, that's just going to be equal to the cosine of theta plus I times the sine of theta. This is going to let us simplify our roots, and this is just Euler's identity. We should know that this is just Euler's identity. This is Euler's identity. So if we take a look at our roots, if we take a look at our possible values for z, we've got this e to the 2 pi I over 3, we've got this e to the 4 pi I over 3, but what does that really mean? Well, we can go ahead and expand them using Euler's identity, so to help us, really simplify them. So if we've got, let's say, we know z is equal to the cube root of v times, we know that z is also equal to the cube root of v times e to the 2 pi over 3i, and we also know that z is equal to the cube root of v times e to the 4 pi over 3i. So let's use Euler's identity to expand these out. So this is fairly straightforward. So if we take a look at e to the 2 pi I, I think you'll find 2 pi over 3 is just 120 degrees. So if we draw that on the unit circle, it's just going to be around here. So that's going to be, and 4 pi over 3 is 240 degrees, right? So that's going to be around there. So if we go any further, we're just going to go back to where we came from. So we go e to the 2 pi over 3, we go e to the 4 pi over 3, and we go back. So there's 3 different roots here. I just wanted to make that clear. But anyway, this helps us because now, if we want to take e to the 2 pi over 3i, we can rewrite this using Euler's identity. We can see it on the coordinate plane. If we were to just draw that root, it's quite clear to us. But we can do it right here. We know that e to the 2 pi over 3i, that is going to be equal to the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. So that's just going to be equal to the cosine of what's 2 pi over 3, that is just 120, and the cosine of 120 is just negative 1/2. And we have I times the sine of 2 pi over 3. So the sine of 2 pi over 3, that's just the sine of 120, which is the square root of 3 over 2. And, whoops, we already figured out. So the sine of 2 pi over 3 is just the square root of 3 over 2. So now we have that. Let's work out what e to the 4 pi over 3i is. And remember, 6 pi over 3i is just going to be e to the 2 pi I, so we don't need to do that. We're just going we'll just be repeating roots. But anyway, either 4 pi over 3i, that's cosine of 4 pi over 3 plus I times the sine of 4 pi over 3 plus I times the sine of 4 pi over 3. And that's just going to give us, well, the cosine of 240 degrees is negative 1/2. And now it's the sine of 4 pi over 3, that's going to be negative square root of 3 over 2. So we're going to get negative I roots of 3 over 2. And so now we can just plug these directly back into our possible values of z. So we're going to get z is equal to the cube root of v. V is just a solution for, v is just one of the solutions for u. And we have z is equal to the cube root of v, times our e to the 2 pi over 3i, which we figured out was just negative 1/2 plus I roots of 3 over 2. And we have z is equal to the cube root of v times e to the 4 pi over 3i, which we figured out was just negative 1/2 minus I roots of 3 over 2. So now, if we work this out, we're just going to get the other possible values. If we just were to write them out, we'd get z is equal to the cube root of t. Sorry, not t, w. Z is going to be the cube root of w times this negative 1/2 plus I roots of 3 over 2. We're just going to get the exact same thing. So we're going to get z is equal to the cube root of w times negative 1/2 minus I roots of 3 over 2. But you'll find out that the w and the v's, so we've got 6 different roots for z, but we should only really be having 3 because it's a cubic equation. But you'll find that some of them are exactly the same once we actually work them out. So let's refer to the substitution. We know that y is equal to z plus s over z. So we know that y is equal to z plus s over z. So what can this tell us? Well, we know that s is negative e over 3, so let's write that. So we know that this is z minus e over 3z. That's what y is equal to. That is what y is equal to. But we also know that, let me rewrite this. We know that VW is equal to negative e cubed over 27. So we know that the cube root of VW should be the cube root. This should be negative e over 3. So now, if we get the cube root of v times the cube root of w, we're going to get negative e cubed over 27. Hold on, I made a mistake here. Actually, that's not correct. Let me go back. We know that the cube root of VW is just going to be negative e over 3 because VW is negative e over 3 cubed, so if we take the cube root of that, we're just going to be left with negative e over 3. So we know the cube root of VW, the cube root of v times the cube root of w is negative e over 3. And now we know that the cube root of v, or we could rewrite, either way, we could write the cube root of w is equal to negative e over 3 times the cube root of v. And this is very interesting. This is very, very useful as well. Because we just figured out that y is equal to z minus e over 3z. So if we plug in y, if we plug in one of our values, let's say y is equal to z minus e over 3z, we know that one of our possible values of z is just the cube root of v. Whoopsie, let me go back here. Let me zoom back out. So we know that one of our possible values of z is just the cube root of v. it's the cube root of v. And then we have minus e over 3z, which is just the cube root of v. But guess what? We have our cube root of, it should be the cube root of v. But guess what? We have this negative e over the cube root of v is the same thing as the cube root of w. We just proved that right there. So we know that y is going to be equal to the cube root of v plus the cube root of w. This is one of our possible values for y. This is one of our possible values for y. So now, that'll give us one of the possible values of x, by the way. So we just figured out that, but this is also good. That's one of it. That's the first root. That's our first possible solution so far. So now we can actually use this for the other roots as well. So what were our other roots? So we know that y is equal to z minus e over 3z. And we know that y is equal to, let's take a look here, the cube root of v plus the cube root of w. That was our first root. So we've also got these other values of z we can use to find new values of y. So some of them will be repeats, but let me go ahead and, so we know y is equal to the cube root of v plus the cube root of v times negative 1/2 plus I roots of 3 over 2. So if we just plug in another value of z here, of course we just figured out that's one of our values of z. So it's going to be z minus e over 3z. So there's our z minus e over 3 times that z. So 3 times this other possible value of z is going to be 3 times the cube root of v times negative 1/2 plus I roots of 3 over 2. So we can use our fact that we figured out earlier. So we know that negative e over our fact that we figured out earlier, if we go back and have a look at it, we know that the cube root of w is equal to negative e over 3 cube roots of v. So we have negative e over 3 cube roots of v right here. So we could rewrite that as a cube root of w. So let me rewrite this. This is going to be the cube root of v times negative 1/2. All I'm doing is just finding new values for y by plugging in different values of z. Times I roots of 3 over 2. And we can replace this with a plus the cube root of w. And then we have this over this negative 1/2 plus I roots of 3 over 2, which we can rewrite as negative 1/2 minus I roots of 3 over 2. We can rewrite it as that, because 1 over negative 1/2 plus I roots of 3 over 2, you can verify this for yourself, but that's just going to end up being the conjugate. It's just going to end up being negative 1/2 minus I roots of 3 over 2. You can verify that for yourself, but I'm not going to prove it here. Should be fairly straightforward. But so now that's our second root. This is another solution. So now let's just plug in a new value for z. What is another value for z we can use? Well, we know that the last value of z we can use in terms of v right here was this one. It's just going to be the conjugate of the last one. So it's going to be, let's take a look here. It's going to be the cube root of v times negative 1/2 minus I roots of 3 over 2. That's our new value for z. And then we have z minus e over 3z. So we're going to have our z right there. Our z minus, so we're going to take our minus e over 3z, but that's just going to end up giving us just our plus cube root of w again, because minus e over 3z, that's going to give us minus e over 3 cube roots of v, so that's just going to give us the cube root of w again, exact same logic as last time, and we take the conjugate, And so we're going to be left with this as our next solution. So now, if we plug in these other roots, we're just going to get the exact repeats. You could try them for yourself. You could plug in these other values of z in terms of WB. You're just going to find that you're going to get these exact solutions again. So we've got these three solutions right here. So our final one, which we found out, was just the cube root of v. Y was equal to the cube root of v plus the cube root of w. So we have our three solutions. So that's our first solution, that's our second solution, and our third solution right here. That's our second solution, and that is our third solution. And all I was doing was just plugging in different values of z, and you'll find that you will get repeats, but just try it for yourself. Plug in these different values, and you're just going to get, you will get our roots. But if we go back, what was y equal to? We made this substitution. That earlier on in the video, I'm pretty sure, if I can find it, we made the substitution. This is the first substitution we did. We did x equals y minus b over 3a. So we were trying to find our roots x, but we've got it in terms of y. So x is going to be y minus b over 3a. So our x values, our three x values to any cubic equation. So we know that x is equal to y minus b over 3a. So it's going to be y minus b over 3a. So we take our y values and then we just subtract b over 3a from them. So our first solution to any cubic is going to be the cube root of v. Cube root of v plus the cube root of w minus b over 3a. That's our first solution to any cubic. Our second x value is just going to be this. So let me rewrite it. It's going to be the cube root of v times all of this business. So negative 1/2 minus, so I'm going to write the plus first. I'm going to write the plus version, plus I roots of 3 over 2, plus the cube root of w times negative 1/2 minus I roots of 3 over 2, minus I roots of 3 over 2. And then we have our minus b over 3a, we can't forget that. So that's our second root to any cubic equation. And our final solution is just going to be the cube root of v times all of this business. So it's just going to be the conjugate of the previous one, negative 1/2 minus I roots of 3 over 2 plus the cube root of v times negative 1/2 plus I roots of 3 over 2, and then we have minus b over 3a. And this v and this w, these are all just, those are just the roots of this v and this w right here. Those are just in terms of our values that we got earlier. And we could write it out, but it would be pretty large, but this is the simplified version. So these are our three possible roots right here. These are our three possible roots. So don't get confused here. All we need to do is just plug in the v and w minus b over 3a, and these are going to give us our possible solutions to our cubic. So if we look at v and w, v was just one of the solutions to u, and our u was just a solution to z, and z was just in terms of y, which was in terms of E and F were just in terms of A, B, C, and D. So it all works out very, very simply. So all we need to do is just plug in our V and our W, which are all just in terms of other variables, and that's just all constant variables, and that's just going to give us our solutions. And we are done.